it's working. Looks like.
Good.
Cool. All right. Hi, everyone. I'm going to wait a few minutes for people to join, but welcome to Interactive Stargazing 2.0. Do you like my background? It's the Godot. Hi. Hi, everyone. Yeah, we're going to wait maybe about like a minute or two just to let people join here. Give everyone a second. Hi. Yeah, I'm super excited about our stream tonight. Hi, everyone. Hey, yo. So welcome, everyone. My name is Hannah. I am a research assistant here at Lowell Observatory, and I'm also an educator. Some of the research that I do here is near-Earth asteroids, but I also do research on Mars at NAU. I've done research on stars, and a fun little tidbit part of research that I've done is actually on arthropods. So I studied spiders. That was just to get a foot in the door in astrobiology. It was really fun. So I'm really excited to show you guys so many cool things tonight with Interactive Stargazing 2.0. We're going to be looking at a whole bunch of cool things right now. Right now on the screen I have a bright star, Regulus, and I'll be telling you all about that here. Just a second. Oh, it looks like a satellite just passed by in the bottom right corner. That was pretty cool. So I'm going to, yeah, just again, wait maybe just like one more minute for people to join. Let's put this now viewing. Oh, hi everyone, welcome. Okay, so it seems like most people are tuned in. So again, welcome everyone to Interactive Stargazing 2.0. Tonight we're going to be focusing on one of the constellations that's actually setting in the sky right now called Leo the Lion. And so the reason why I decided to focus on Leo the Lion tonight is because, again, it's setting in the sky and we're not going to be able to see it, very shortly here. So I thought it'd be a really good chance to focus in on one of, I think, my favorite zodiac constellations. I really like Leo and Gemini just because they look a lot like what they actually are. So Leo is a lion. And so I'll show you here what Leo looks like. So here's Stellarium. This is a free app that you can get. It's online, you can download it, it's on the web. So let's go over to Leo. So Leo is in the southwest right now. It is setting. So I'll zoom in here on Leo. Here's our beautiful Leo the Lion. And I wish I could turn it around. Can I turn it around? No. I'll just leave it like this. So as you can see, Leo is setting. It's getting very close to the horizon here to the west. It's in the southwest. It's setting. It's going to be slowly going down. You can see Gemini is basically gone. We have Cancer here. And so Leo, we have this backwards question mark that I say that is actually the mane of the lion. And so this backwards question mark here, that's the mane. And then these two stars go out here to these two stars and they make a rectangle. And this is the body of Leo the Lion. And then we have these two, this makes a triangle, and that's the tail of Leo the Lion. And so there's some really cool stars here. You can see that the names pop up. So we have Algeba, Regulus, and Denebula. So let's start off with Algeba. So I can zoom in here to Algeba, and I don't know if Stellarium will make it out, but Algeba, oh, there it is. You can just barely see it in Stellarium. So Algeba is actually a binary star system, and Algeba actually means the forehead of the lion. So if we zoom back out really quickly, I mean, it's kind of, in that area, but it's actually, I believe, Arabic, Algeba, the name. So it's a binary star system, so there's two stars, they're orbiting around each other. We'll get a chance to look at that tonight. So that's one of the stars I'll be focusing on in Leo. We also have Regulus, which is in the screen right above me. That's Regulus. That's a live feed of it. And so Regulus is the regal star in Leo the lion, and it actually means the little king. And so it's a very, very bright young star. And this is actually a really interesting star because there's actually four. It's a quadruple star system. And so we'll talk more about that one. And then we also have Denebula, which is the tail of the lion. And so if you guys are new here to interactive stargazing and especially 2.0, what I'm going to be doing tonight is we're going to be using our plane wave telescope to move around and look at all different objects. I'll be able to show you live images of them, talk a little bit about them, and towards the end, if you guys have any requests for things that might be up in the sky tonight, I'll be able to move the telescope and show you that object. And so I'll show you here how we're going to be moving the telescope. So we have our plane wave interface, and that is how we move the telescope. There it is. And so here is our plane wave interface. So again, we have this telescope at the Giovanni Open Deck Observatory. They're on these two big, oh, it's actually right behind me. Here's the Godo. And these telescopes here, the really tall ones, these are our plane waves, and so they move super fast. They're really cool. And we're using this one here that has a camera. It's called a Malancam, hooked up to the back of it. And so it can take live images. And so this is the interface that we use to move the telescope around. So as you can see, I have some things pulled up here. And we also, just like on Stellarium, have a view of the whole entire night sky. And so right now, the telescope is pointing at Regulus. So let's talk a little bit about that. Let's pull it up here. So here is our beautiful star Regulus. Let me actually put in the name Regulus. It says Orion Nebula, but that one's actually set. Regulus. There we go. So here is our regal star Regulus. So like I was saying, it's a quadruple star system. So there's two pairs of stars in Regulus. We actually can't make it out with the telescope. They're very, very close together. I mean, I can try to zoom in here on Regulus, and if I look to my left over here, it's because this is where I'm actually controlling everything. And so I can zoom in to Regulus here. You can see how it's a very bright blue star. It's so beautiful. And so Regulus has a companion, and then I believe that one has also a companion, and then Regulus has one too. So there's like two, the binary, both each have their own companion, and they're both going around each other, so it's a quadruple star system, which I think is ridiculous. It's so cool that there's stars that not only is there two, but there's more. And so how that happens is when stars are born, they're born in this big cloud of gas and dust, and it's called a nebula. And maybe, not denebula, just a nebula. I know it sounds a little similar, but so this nebula is basically just a space cloud. It's made up of gas and dust, and it's so dense that gravity collapses and the particles in that nebula start to smash together, and we get nuclear fusion, and that's how we get some baby stars. And so when this happens in the nebula, it happens to kind of collapse in multiple points more often than not. And so the sun, for example, doesn't have a partner. And so that's kind of uncommon because most of the stars that we see in the sky actually are like twins, and that's the binary. So they're two or even more, just like Regulus. So it's a quadruple star system, which I think is, again, super fun. And so, yeah, that's a nice one. Again, very blue. And so, oh, that's a satellite, I think, yeah. So you could see how for a second there was a big streak right in front of the star. And so that was just a satellite passing right in front of it. And so we might see that often tonight. And how we can tell that it's a satellite is I wish I took a picture of it, but when that happens, you can see that it's almost like little dots. And so that's it taking pictures of it kind of like moving. So it looks pretty cool. Anyway, so the color of Regulus is blue. Again, it's very regal looking. I associate like blue and purple with like, you know, royalty. And so it's very, very blue. And the reason why Regulus is very blue is because of its temperature. And so it's a very, very hot star. And hot stars tend to look more bluish, kind of white. And think of it kind of like a flame. Although stars aren't on fire, they're made of plasma. We can think of kind of this color like a flame. So the hottest part of a flame is blue. And when it starts to cool down, maybe towards the top of the flame, it gets more yellow, more orange. And so that's like cool, even though it's still really hot, right? And so these hot stars, they're very, very blue. And they're really young usually, these really hot stars, or they can be. And so they burn through their fuel a little bit faster than some of the cooler stars. And so the cooler stars that we'll see tonight will be a little bit more yellow and orange. And so, you know, they're cooler, they're going through their fuel a lot slower, and they're usually older stars. So is it called a quaternary star system? I think it's just called a quadruple, the quadruple star system. But it could be called a quaternary star system. From what I've seen literally on Google, it's just quadruple star system. And also I'm looking at the chat right now, so if anyone has any questions at all, or, you know, suggestions, anything, like feel free to pop it in the chat. I'm keeping an eye on it. So if the stars were actually burning, they wouldn't last very long. Yeah. Exactly. And also, there's no oxygen up in space. And so if you think of a fire, like a flame, there needs to be fuel to feed that fire. And that's oxygen. And in space, there's no oxygen. And, you know, one of the first things that you should do if there's a fire, like an unintentional fire, is you try to suffocate it. You try to get all that oxygen out of there. And then it goes out. And so again, same with space. There's no oxygen. There's no fuel for fire to burn. And so they're not on fire. It's plasma. Super crazy matter. So yeah, there's our beautiful star. So let's move on to one of the other stars that we have in Leo, Algeba. That's a cool one. So let me move to my plane wave interface so you guys can actually see how I can move it. I'm losing my mouse here. There we go. All right. So here's Leo the lion. And as you can see, if I click something, that is actually where my telescope wants to go. And so Algeba, I'll zoom in just so you can see it. I can see it. Well, maybe it brings up too many things. So I'll just click right here and you'll see it says Algeba. And so when I click go to, the telescope will go to, and then you'll actually see the image above me change. So let's go to Algeba. All right, let's let it settle in here. So I am taking a little bit of a longer exposure. So let me shorten this so I can actually make out both of the stars. So I'm really lowering my exposure here so we can see it. They're very bright. Oh my goodness. Still can't make out. There we go. Oh, too much. Gotta up it just a little bit more. And so Algeba is, again, a binary star system. So we can zoom in and you can see how close they are together. Okay, I gotta actually move it on here so you can see it very well. There we go. There is Algeba. So let me change it now because we're viewing Algeba. Perfect. Yeah, and I am in full control of the telescope. So how we used to do the interactive stargazing is we actually had someone moving the telescope for the person who was doing the interactive stargazing. But now it's just one person doing it all, which I think is really fun. You know, I actually get to move it. I can zoom in and tell you guys the process of like how I'm doing things. So yeah, I think it's a lot of fun being able to control it. Okay, so double star. Now I really want In-N-Out burger. Oh, dang it, why'd you say that? No, I do it. It's late, I'm hungry. My wife says it looks fake. What makes it look like that? Why can't we see them in better detail? Is it just the limitations of the telescope? That's a very good question. So I assume by what you mean is that, like, why don't we see like the whole star, you know, like kind of like how we see the sun, you know, in pictures we can see almost like details and everything. And so yeah, it is limitations of telescopes. So I mean, the only star we really have seen in detail is the sun. It's so close to us, and so we can study it very well. But other stars, it's almost unfathomable how far away they are. So even the closest star to us is like, you know, 3 to 4 light years away, Proxima or Alpha Centauri, and we still can't even make that one out. We can't even see like the surface or any details. I mean, we're working on it. We're working on, you know, getting a better image of other stars, but they're so far away. So when we look at bright stars with the telescope, we're basically just magnifying it. You see them as little points in the sky, and then with the telescope you zoom in and you can see some color, you can see, you know, if they have a companion and things like that, but they still kind of look like just points in the sky. So, and that movement that we're seeing is from the atmosphere. And so I don't think it's very humid in Flagstaff right now. I can actually check the humidity that it is, but we're looking at light from very far away, and it's traveling again like light years away, and it's that light's going through our atmosphere that's made up of all these different gases that are all different densities and weights, and so they're all kind of moving around like water. So you know, if you look at something like at the bottom of a lake or like the bottom of a pool or something, and it looks like when the water's moving like a rock is moving or something, but it's not, it's just the water. So it's the same thing like with these stars and these things. It looks like they're moving around, but they're not. It's the atmosphere kind of bending the light. And so in Flagstaff, right here, it is about 25% humidity. So it's not too humid right now, which is nice. Okay, let's see. Yeah, usually someone was outside operating the telescope. It was, I know, it's really nice in the summer. It's, you know, spring, summertime right now. And it was really hot earlier in the evening. And so this will be nice for when it does get cooler outside. And as an astronomer, what are you guys most excited about learning from the James Webb Telescope? And is June still the great unveiling? So I think for me, I don't know exactly, I don't know if I could speak for astronomers as a collective on like what people are excited about, but at least for me, I was reading this article about like the Hubble constant, and if you guys don't know what the Hubble constant is, it's basically like a value that tells you how much the universe is expanding. And so we don't have like a definitive number for that. Different instruments actually calculate different numbers. So like the Hubble telescope calculated something that's much different than like the Planck telescope, which I forget what they do. Hubble, I'm so bad with instruments. If anyone knows in the chat, please leave it in the chat. But they calculated different constants basically. And so James Webb, with its, you know, precision and everything, will hopefully be able to get a very, you know, pretty precise number of how much the universe is expanding and at what rate it is. So I'm excited for that. I'm also excited for the pictures. I think they're going to be really cool. And so let's talk a little bit about Algeba here. And so again, it is a binary star system. It means the forehead of the lion. The name, like the catalog name, I guess, for the star is called Gamma Leonis. And so a lot of stars actually have like a Greek alphabet associated with it. So we have, you know, alpha, beta, gamma, delta, all those stars. And then what's following is the constellation. So Beta Leonis. So I think that means that it's actually the second brightest star in Leo. So that's pretty cool. And yeah, it's double star system, and you can just barely make it out. I actually really enjoy looking at this one just visually through the eyepiece because it shows people how close little binary stars can get. I think another fun one, I haven't actually seen it before, but Sirius B, those really tight binaries. Yeah, 60 to 70 kilometers per second per megaparsecs. Yeah, exactly. That's what the Hubble constant is. It's very interesting value. All right, but so let's go on to our next object, because right now we're focusing on the bright stars just because I think they're really interesting, but I also want to get some galaxies for us as well. So I'm going to turn to my left here, and we're going to go, well actually let me move it on here. There we go. Now we're going to move all the way to the end of Leo the Lion, and we're going to go to Denebula. All right, and I'm going to click go to, and you'll see the image above me hopefully change. There we go. Let's see what that looks like. Oh, there she is. I'm going to make it look a little bit brighter, a little bit more exciting. Ooh, it also looks very blue. Another very blue star. So I also believe Denebula is Arabic, and it means the lion's tail. And oh my gosh, I said Beta Leonis for Algeba. I think I said Gamma Leonis at first and then switched it. Oh my god, my nose switched up. So Denebula is Beta Leonis, and this is the second brightest one. Algeba, Gamma, Alpha, Beta, Gamma. So the third brightest one is Algeba. This is the second one, Beta Leonis. And this is also a binary star, but it doesn't look like we can resolve it. Let me change the name. We're not looking at Algeba anymore. We're looking at Denebula. Beautiful. Yeah, I don't know if we can resolve this one. We could try. I mean, we saw how it looked when that exposure was down. No, doesn't look like it. I don't know what kind of telescope you would need to resolve it. Let's see what it says. It says, is a double star, unresolved to the naked eye, have a combined magnitude brighter than it. Yeah, so I think it's a trickier one. Let's make it brighter again. So beautiful. So yeah, this is our tail of the lion in Leo. And this is the last bright star that we will actually be looking at in Leo. But again, I think it's also a very beautiful, young, hot star. We've got that nice blue, kind of white hue to it. And I really like the crosshairs that you can see, and that's because of our telescope. And so, yes, we are using our 17-inch plane wave telescope. And in the mirror, you know, we have like our, I forget what they're called, brackets, you know. They hold the telescope together. I forget what they're called. Brackets. It's not brackets, something like that. And anyway, that's actually what we're seeing. That's what's making those kind of crosshairs there. If anyone knows what the name is, it's not the secondary holder. Yeah, but there's trusses. Is it trusses? I can't remember. Yeah, but so that's actually what's making that crosshairs there in the star. It's just an artifact. It's not actually there. So very, very pretty. I really enjoy seeing that, and the kind of blue hue around it. Very nice. Okay, let's see what we got. Braces, yeah, something. I don't know. It's gone. Let's see. Thank you, everyone, for such nice words. Despite the different readings and the speed of the expansion of the universe, is there an agreed-on conclusion that it is slowing down or speeding up while expanding? So it is agreed upon that it is speeding up. And so it's just what's the rate of that expansion, you know? Like, is it like 5 miles per hour? Is it like 10 miles per hour? Like, it's expanding and it is speeding up, but like, by how much? So, yeah. And it's funny because when we look at the beginning, like, this is going to sound So crazy. But when we look at the beginning of the universe, so when we look back in time, so that's what telescopes do. When we're looking at all these different things, we're looking back in time. We're doing literal time travel. That's what I tell people whenever we're looking at something. I especially tell kids that. I'm like, you're doing time travel. You're looking back in time. And so when we look at galaxies really far away, you know, like hundreds of millions of light years away, you know, those are from the beginning of the universe. And we actually see that objects and galaxies that are, you know, really, really old towards the beginning of the universe are actually moving how we think they should be moving, you know, just how physics works. You know, they're expanding at a normal rate, you know, things towards the center of galaxies are actually moving faster towards, and then at the outside they're slower. And then when we see things like kind of in our area of space-time, we see this weird artifact, which now we know is, well, I guess, I don't know if we know, but the theory is dark energy. And then we see that galaxies are actually rotating differently too, which is really interesting. So again, I really hope James Webb will be able to tell us more about this in detail, you know, just show us so many cool things. Do you have any advice for us amateur astronomers with small telescopes? Yeah, so it depends on kind of your level. If you've never used a telescope before and you're having some issues with your telescope, I would say practice during the daytime. I know it sounds counterintuitive. Don't look at the sun. Don't look at the like sun or anything, but during the daytime, I would practice looking at, you know, things like mountains or trees or things like in the skyline that you can kind of align your telescope to, and then align your finder scope, and, you know, just try to see how it is moving your telescope during the day, and then you kind of can get used to it. And once you have things lined up, then at nighttime, I would start focusing on brighter stars. And so things like in Leo, we have, you know, Regulus and Nebula. Up tonight, some of the brighter stars, there's Vega that's up tonight. We have Arcturus, Regulus, Spica, and so just some of the brighter stars. And I would get, you know, maybe like a sky app or something. Even use Stellarium here. You know, Stellarium is such a good tool for looking at these different things, and it's free, it's online, you don't even have to buy anything. And so, you know, you can see kind of where they are, and if you get it on your phone, you can actually like have the GPS aligned, so when you move your phone around, it can kind of tell you where it is. And then I'd practice looking at bright stars, and then from that I would start looking at, you know, still brighter but a little bit fainter objects, so maybe like binary stars, and then you can start, you know, getting into clusters and things like that. And so that's advice that I have for actually using the telescope. And I personally, I always like try to recommend people get accustomed to manual telescopes first before they get to the automated ones, because with automated ones you have to do like star lines and everything, and it's best that you know actually where the stars are and like how to use telescopes before you can get into all that automation. I think it's a lot easier when you actually can figure things out yourself beforehand. So definitely a manual telescope too. So yeah, here's Arcturus here. So again, let's look at some things in Leo here. So I wanted to start looking at some galaxies here. So what's fun about Leo, there's actually a triplet of galaxies. I always forget if they're like right below or right above it. They're right here. Here is the Leo triplet. So I want to take a look at some of these. And so this one's my favorite. I'm going to actually go to this one first. It's called the Hamburger Galaxy. And the actual name is NGC 3628. And it also has the name Sarah's Galaxy. I like that because my little sister, her name is Sarah. So let's move it to that one. And so actually what I'm going to do for this one is I'm going to type it in because I don't want to scroll in and find it. So I'm just going to type in NGC, what is it? 3628. 36. Perfect. And so if I click on it, it should go right there, yeah, see? So it's centered in right there. All right. And so all I have to do is click go to, and then it should go there. There we go. And so now my image is going to change here in just a second. And so now what I'm going to have to do is actually change the exposure time so we can actually get it, because right now there's nothing. And that's because you can't really see it because we're just looking at nothing. So let's change our exposure time. So what I'm doing kind of behind the scenes here is I'm adjusting the sensitivity of our camera, which is a Malin cam, and then changing the length of time that we're allowing the light to hit the camera. So I am adjusting it for about 20 seconds. I'm going to see how that looks. I'm also just changing some little details in here. And so we're going to allow maybe 20 seconds for our picture to show up. And in the meantime, let's see what you guys are saying. Hi from the Godo. Hi, everyone. Oh, there it is. I never know which galaxies are above the horizon, so it's a 50-50 chance when asking for the NGCs. Yeah, it's the same. The in and out galaxy. Yeah, any planets available for viewing? Unfortunately, the planets are actually up during the morning right now. So if you're an early riser, you're able to see the planets. But late in the evening, there's no planets out right now. Maybe just a little bit ago, Mercury was up just during sunset, but nothing right now. In a few months, I think around July, August is when the planets should be up around this time, which will be exciting. So we're just gonna wait until we can get some planets. But in the meantime, we got some cool galaxies. We got the hamburger galaxy here. And I'm actually going to adjust the exposure time just a little bit more and increase the sensitivity of my camera. I changed it about 5 more seconds so we can get a nice view. And then let me change the name here. We're not looking at the nebula. We're looking at, I'm not putting NGC, I'm putting hamburger. Hamburger. Nice. Let's see. Oh, that's looking so nice. Are there other 2 galaxies for vegan astronomers? You know what's funny is, so there's Leo, and Leo actually has a friend right next to it called Leo Minor, the little one, the little lion. And in Leo Minor, there's the sliced onion galaxy. And I don't know, I think it's just an elliptical galaxy. Could look it up, but yeah, it's called the sliced onion galaxy, which I think is funny. It's like, you know, the onion ran away from the hamburger galaxy. So there's that one. Hello from Colombia, hi. Is the dwarf planet Ceres up right now? I can check on that. I don't know if it is. Let me switch to my stellarium here so you guys can see. I know there's a search feature on here. Search. I don't use stellarium too much to search objects up. I usually just have it and kind of look around. Oh, here we go. Ceres. Ceres 1, 2? What's that? Oh, no. Ceres is below the horizon. Yeah, a lot of those exciting planets and things, they're all below the horizon right now. So, unfortunately, Ceres is not up tonight. But that's why we're looking at galaxies. Could we see a star in Pisces? Oh, I don't think Pisces is up either. So I'll show you the zodiac constellations that we have up right now. So we have Gemini, which is setting very low. Is this adjusted for the right time? No, that's okay. This is basically what the sky looks like. So we have Gemini setting, Cancer. We have Leo. Oh my gosh, actually, I think I can I put the, no, I don't know how to use this. Cancer, Leo, those are the zodiac. We also have Virgo, Libra, we have Scorpio right here, and those are the zodiacs that are up right now. So the zodiac, if you guys don't know what the zodiac is, that's the path in the sky where the solar system is. And so if you think about it, the solar system's kind of like on a flat plane around the sun. So what happened is, you know, when the sun was being born in the nebula, not the nebula, the nebula. all of that gas and dust and stuff was around this little baby star, and the baby star is spinning really fast, and so it's spinning that material out like pizza dough. It's flattening it out. And so we have a flat solar system. Not really, it's like 3D, but the solar system is on this flat plane. And we can project that line into the sky, which is called the ecliptic or the zodiac. And so that's why everyone has their own zodiac, because that's also where the sun goes. And so when you're born, your zodiac is what constellation the sun is in. And so if it's like your birthday right now, your zodiac constellation is not going to be up right now. It's up during the day. That's where the sun is. So, but yeah, Pisces isn't up right now, basically. Great galaxy view. Yeah, let's go back to our galaxy. Looks so beautiful. Hamburger galaxy. Let me look up some cool things about the hamburger galaxy. Let me see how big it is and how far away it is. It is, it's an unbarred spiral galaxy about 35 million light years away. And it was discovered by William Herschel. That's cool. And it's about 13 billion years old. That sounds about right for a galaxy. 35 million light years away. Yeah. Cool. So, an unbarred spiral galaxy. What does that mean? So we have different galaxies. There's actually like a chart of galaxies. And we have ellipticals and we have spirals, and there's some in between, some kind of out of that. But yeah, basically there's ellipticals and spirals. And in that category of spiral galaxies, there is some of them that actually have like a bar in the center. So they called it a barred spiral galaxy. I think there's one up tonight actually that we can look at. So there's a barred spiral galaxy, and then there's some without a bar. So they're just, kind of like a pinwheel looking shape. And so this one, the hamburger galaxy, is an unbarred spiral galaxy. And so what we're seeing, I'm going to zoom in actually on this hamburger. Oh, so cool. So I'm actually going to stack this image. I'm going to see if we can stack it, just so we can get some of that noise and get it a little bit more clear. I totally forgot about the stacking. Cool. So we're going to stack it, see how it looks. And so what we're seeing is all this dark kind of band. Those are the spiral arms of the galaxy. And that's actually where all the activity in galaxies happen, is in the arms. And so there's all that gas and dust in the arms of the galaxy. Yeah, the dust lane. And that gas and dust is making baby stars. And then those baby stars have planets around them. That's where, we are in the arms of our Milky Way galaxy. And then in the center, you can see it's really, really bright. And that brightness comes from a density of very, very old stars called the core of the galaxy. And in the core of the galaxy, all those stars are kind of gravitationally bound to one another, and they're all going around the central supermassive black hole. So in the center of galaxies, we do think there are black holes, but they're supermassive. They're really big black holes. And then all the stars kind of go around them in the center. And what's fun about that is there's some objects up in the sky called globular star clusters, which we can take a look at as well, that we actually think are the cores of proto-galaxies that the Milky Way sucked up. So there are these little ones that the Milky Way sucked up, and they're going around the outside. Just a theory. Meteor shower Monday night. Oh my God, I have to tell you guys all about that. So yeah, on Monday, while this stacks and we get some of the noise out of the way, I can already tell that it's looking a lot better. But yeah, on Monday night, if you live in the Southwest United States, or Northwest, Mexico kind of area, there will be a meteor storm coming from, I believe it's the comet Schwarzmann-Wachmann 1. My colleague Teddy Coretta would be very upset that I don't know the name of it. But I believe it's coming from that comet. And so this meteor storm is going to be different from a meteor shower, because but at least in Flagstaff, I don't know the time conversions, but at least here in Flagstaff from like 8 to 11 o'clock at night, these meteors, they'll be, I think, at least almost 1,000 an hour. It's going to be intense. It's going to be like those things that you see in movies, you know, when movies show meteor showers and it's just like falling stars constantly, and you're like, that's not what happens during a meteor shower. That's what happens during meteor storms. And I actually didn't know about meteor storms until I started working on asteroids. I thought it was just all, you know, people not understanding how like meteor showers worked, and you know, popular culture seeing those paintings and stuff, but they actually happen where there's so many falling. And so when I say falling stars, they're not actually stars, right? They're just little rocks falling through Earth's atmosphere and burning up. And so because when they do that, they burn really brightly, so people think it looks like a star that's, you know, shooting through our atmosphere, but it's not. They're little rocks. Sometimes they're space debris, unfortunately. And what I tell people is, if you're really lucky and you wish upon a shooting star, it could just be astronaut poop, but you don't know. Yeah. Space. I think this picture looks really nice. I'm gonna actually take a picture of it. And once I take a picture of some of these things, I can actually edit them. So let me see. That's not what I want. Adjust curve. So we can like get this color curve, and I can just bend it and get some adjustments so we can see, ooh, some more detail. No. Oh, how cool. This is cheating. Cheating just a little bit. Okay, now I'm just messing it up. What's fun is if I mess it up, I can just click reset. And then it's fine. All right, so it is 10:50. I'm planning on doing this until I get bored. So we can look at anything. So we have the hamburger galaxy, we looked at the nebula, Algeba, Regulus. Let me look at one more thing in Leo, and then I'll start doing some requests. So let's go to one more deep space object in Leo. And so I actually have a list of things. If you guys, there's the skylive.com, which actually tells you objects that are in constellations. And so that's what I use. And so let's do one more. Let's do another Leo triplet. One of the Leo triplets. So we're at the hamburger. So let's go to M66. We'll go to that one. So let me switch here. All right. Oh. M66. Perfect. And you can see it's right next to it. My little yellow thing popped up right next to it. And let's go. 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 And now I have to stop this exposure though. Yep. It's yelling at me. All right, so we just moved it. So let me show you guys my thing. And I'm going to stop this exposure, and I'm gonna undo the stacking. And we're gonna let's do the same exposure time, about 25 seconds. Let's see how that looks for M66, and then we'll start stacking it once we get it. So let's back up. Here's our last view of that beautiful hamburger galaxy. I don't know if we'll see the sliced onion one tonight. Maybe. And while we wait for that, let's see what you guys are saying. There's only onion in the burger, no coleslaw veggie. Nope. Libra. There are some bright clusters up right now. M13, yep, M13 is up. Virgo galaxy cluster. Okay, could do that one. Sombrero. Some of the things the other comments, so funny. Can you take us to Orion, please? So unfortunately, Orion has set. So Orion is not up for us tonight. So I'm just adjusting this exposure. It's just a little bit too long. We're getting a little bit of over exposure from the core. Actually, I don't know. That kind of looks good. We'll see what this does. I put it just to 23 seconds instead of 25. Let's see. It's almost done. We're at 20 seconds now. Yeah, there is the cigar galaxy, there's the Sombrero galaxy, there's the hamburger. Oh, I think that did look better. So let's start stacking it. Well, maybe I'll lower it just another second or two. Just because I can. And then I'll stack it. They should change the burger to taco. I wonder if there is a taco galaxy. Let's see. Taco galaxy? No, there's no taco galaxy. There's a restaurant called Galaxy Taco that keeps popping up. Can you try to control the resolution of the image, please? Yeah, so it's a little difficult because what I'm doing, oh, look, we can get one of the other Leos. It's right there in the corner. So what I'm doing is I'm like zooming in on our picture. So this is what our picture usually looks like. It's all kind of zoomed out. And if I zoom in, it kind of makes it a little bit more blurrier. And so that's the reason why I'm stacking the image, is to kind of get rid of that noise from around it, make it look a little bit more smoother. And so I'm not a professional astrophotographer by any means. I wish I was. Some of the pictures that I see some, people who do astrophotography get just blow my mind. I wish I could do that. I would say I'm very much a novice, very much a beginner. And we don't have a filter wheel on our telescope. There's no filter. It's just raw light. And the reason why that is because this telescope that we use, the plane wave, the Malakan system, this is meant for, it's not for professional astrophotography, really. It's more of an educational thing. And so when people come up to the open deck observatory, we can quickly move it to different objects and show people things and talk about things and educate people on objects, compared to like just letting it sit there and get a beautiful, beautiful picture. And it can do that. It can definitely do that. But the main purpose of it is to be able to have people see all these different galaxies and different things in like 5 minutes. We can move the telescope to so many different objects in 5 minutes and get really good pictures, see a lot of detail, which I think is really cool. So yeah, and I think it does have more imaging tools, but again, I'm not super professional on it. And so I'm changing the name because this is not the hamburger galaxy anymore. This is M66. That's what we're looking at. So let's talk about M66 here. So it is stacking a little bit here. So we can see the bright core. Let me go over here. The bright core in the center, that's what I was talking about before. That's where the supermassive black hole is. That's where that density of stars is. All surrounding there, they're all really, really close together and really bright. And then all around the edges there, you can see the dust lanes, the arms of this spiral galaxy. Is this one a barred? I don't think it is. I don't see a barred. But let me double check. I don't want to be wrong. And what's funny is I'm just looking up all of these things. Yep, it's just an intermediate spiral galaxy in Leo. And so yeah, I really like it. You can really see a lot of detail in the arms. I'm going to zoom in a little bit more. Can I? Maybe I'm already max zoomed in. But you can see how it's darker in some of these portions. So that's where the gas and dust is really thick. It's really, really dense, blocking out a lot of the light from the stars in there. And then around it, you can see how it's a little bit brighter. And that's where those baby stars are, or just regular stars, main sequence stars. Yeah, very nice. And then in this corner here, just, oh, you can't really see it, but he's in the corner. There's a galaxy right there. Yeah. Yeah, so dim the image, all that stuff. Yeah, I mean, if I wanted to spend the time to do that and really mess with this all night, I can. But again, I'm trying to focus on more of the educational aspect and talking to you guys about it and then moving on to something else. I don't want to spend, all night on just one object. So yeah, so there is M66. So let's see, does anyone have any requests? It is kind of getting to that time where I can take anyone's request. I've seen everything that I'd like to see in Leo. Sombrero, I'm seeing lots of requests for Sombrero. I have to see if Sombrero is up. I think it is, but I have to double check. Yeah, Orion isn't up. Whirlpool is. Whirlpool's up. Okay. And yeah, Jupiter is up in the morning. So all the planets there are up in the morning. And yeah, I'm just having fun basically. Sirius, oh, Sirius unfortunately is too low in the sky as well. Sirius is set. Yeah. Too low in the sky. You can see Capella and everyone here. So let's do Sombrero. Let's see if Sombrero's up. Let's go to the search window. Sombrero. Perfect. That's right above Corvus the Crow. So let's zoom in so you guys kind of get a sneak peek of what we're going to look at. We're going to be looking at the Sombrero galaxy. And so this is a very nice spiral galaxy. You can see that dust lane, you can see the center. And so the reason why people call it the Sombrero is because when you look at it kind of with just, you know, with your eye, you can see that dust lane and then you can see the brightness, and people think it kind of looks like the brim of a sombrero, and then the brightness is like the hat. So let's move our telescope to it. So all I have to do on the Planewayne software is just look up Sombrero. And then it should go right over there. There it is. Right there, right above Corvus. Okay. Hopefully there's not a tree in the way. See, here's the thing. Here's the only downfall about not being outside controlling the telescope is I can't see what's going on out there. I can't see if there's any clouds. I can't see if there's a tree. So we're just going to have to see for ourselves. So let's go to that one. Here we go. So we just moved it. Oh, and you can see in my image here, we got some streaking going on, and that's because I moved the telescope while I was taking an exposure. And so it took an exposure of those stars moving. So I'm going to stop the exposure. And Sombrero's small and kind of bright, so I'm going to go down to 14 seconds, and we're going to see how that looks. So, how large is the refractor lens? So we're using a plane wave. It's actually a reflector, and I believe it's 14 inches. Oh, look at that. Let's change the name. I keep losing my mouse. Sombrero galaxy. Beautiful. Look at that. I love that one. She is so cute. I'm going to lower the exposure just a little bit more, just so I can, I don't know, see how it looks. We'll see. Yeah, such a beautiful galaxy. Let me look up some fun things about the Sombrero galaxy. So the Sombrero galaxy is actually called a peculiar galaxy of unclear classification. So like I was saying, it's in between Corvus and Virgo right now. Hi, Chuck, astrophotography. Oh, hi. I think I follow you on TikTok. But yeah, this is a late stream. And so we started so I'm here in Flagstaff, Arizona. We're at Lowell Observatory, live from the GODO, the Giovanni Open Deck Observatory. And so we started at 10 o'clock, but starting the next time we stream, it's going to be starting at 11, so it's going to be even later. But that's good for us because then we can get some really cool objects. So what was I saying? Anyway, about the Sombrero galaxy. It is about 30 million light years away from Earth. That sounds about right. And the radius, so just half the size of it, is about 25,000 light years. And it's about 13 billion years old. Again, that makes sense. Yeah, so it says it's a peculiar galaxy, you know, and like I was talking about earlier, how there's the different classifications of the galaxies. You can generalize, there's elliptical and there's spirals, and then from in there you can go more in depth about the different, you know, galaxies. And so peculiar galaxy, I actually don't know too much about peculiar galaxies. It looks like a spiral to me. So I believe it's just unusual size, shape, or composition. And 5 to 10% of galaxies are actually peculiar. So that's very interesting. I don't think it looks too peculiar. I think it looks very nice. but that's just me. So there's our beautiful Sombrero galaxy. Does anyone else have any recommendations? Let me scroll up in the chat here. Ooh, a comet. I don't know how comets are gonna look. Unless it is like kind of a higher magnitude comet, I don't know if we're gonna be able to get it. I don't know if Stellarium tells me the magnitude of things. Let's see. Oh, let me put this here so you can see. Comet C 2017 K2. Stellarium's not telling me. Yeah, comets, I'm gonna have to look into that one for getting comets and seeing those and looking them up, because I don't know where that one is. If I knew where it is. M97. Oh, antenna galaxy is right below it, right below Sombrero. I know M97 is different. Let's see, is this one up? Oh, the owl eye. Is this the owl eye? I hope it is. Where's this one? Oh, it's an Ursa Major. Okay, let's go to this one. I like this one. So let's go back to our plane wave software. Again, I'm turning to the left. This is where it is. 97. And so for people just joining, or who have been viewing for a little bit but not since the beginning, welcome to Interactive Stargazing 2.0. My name is Hannah, and I'm not a professional astrophotographer. I'm actually a research scientist, and surprisingly, a research scientist you would think would know all about the night sky, but we don't. At least I don't. I don't know all about the night sky. I would try my best to, though. And I think it's so much fun being able to look at the different things, show people different things, and talk about them. So yeah, let's see. This one is an Ursa Major. It's in the Big Dipper. And so we're going to go to this Owl Nebula here. And so we're using our plane wave telescope at the Geo Valley Open Deck Observatory. Right behind me, I am outside right now. No, I'm not. This is a green screen. They got me a green screen to do this. I think it's so nice. Thank you so much, Lowell. And so we're using this telescope here. This is our 17-inch plane wave, and right behind it there is a Malincam. It's a camera. It's just like a DSLR, you know, there's no filter, nothing fancy. We're just, you know, taking pictures of things and seeing what they look like. Right now we got the owl eye, whoop, coming up here. So we're going to change this exposure so we can get it a little bit better. Do 16 seconds, see how that one looks. And yeah, that's what we're doing, just kind of hanging out and showing you guys some cool things. So here is our Owl Eye Nebula. So this is a planetary nebula, and oh, that's getting there. Let me increase the exposure a little more. We're gonna do 26 seconds. I was doing like 16, so I upped it a lot more. I'm just playing with some of the details there. And so this is a planetary nebula, I believe. Oh, and let's change it. We're looking at Owl Eye Nebula. Beautiful. Look at that! We can start to see some color. So planetary nebulas, they're some of my favorite nebulas that are up in the sky. So the reason why I like them is because there are the remnant of a dead star. I just think it's so cool to show people planetary nebulas. Like, you're looking at a dead star. Like, you can still see the dead star. Like, it's still there. Even though it's dead, you can still see it. I love that gas and dust just all around it. So what happens? How does the star die? You know, what's going on? So stars, in the center of this star, there was hydrogen and helium. Hydrogen was fusing with hydrogen to make helium, right? And there's only like a finite amount of hydrogen in the core of a star. And so once it runs out of hydrogen, then it starts fusing helium into heavier elements, and that's when the death starts to happen. So the outer layers of the star start to swell up, and these are just small stars. So small stars, they're like sun-like stars. Yeah, these sun-like stars. I forget what's the range that a planetary nebula can be. I think it's like less than 10 solar masses or something like that. Something. But so the outer layers start to swell up and they start to kind of shed off. And when that happens, that's when we get this gas and dust that's kind of drifting off. I like to say like a bath bomb. So it's kind of shedding off the core of the star. And so what we're left with is in the center there is a white dwarf. And that's the core of the dead star. And so that core now is basically just metal. And it's still really hot. I mean, stars, they're really, really hot. And so it's like really hot metal, and you can still see it. It's really bright. But eventually it'll cool down, and we won't be able to see it, but we can now. And then we can still see the outer layers of what was that star. And then the different colors represent to what elements were in that star. So red usually is associated with hydrogen, and blue, I believe, is like oxygen. So yeah. So I'm just reading the comments, seeing if you guys have any other suggestions. Black Eye Galaxy, yes, we do have the Black Eye Galaxy is up right now. I think I'm gonna take maybe 1 or 2 more suggestions, just because as much as I would love to do this all night, I mean, I'm gonna ask them maybe if I could do this for a while, but I'm not outside. And so there actually someone still has to be outside at the Godo watching the telescopes. And I would feel bad making someone stand outside all night just to watch the telescopes while I'm in here having fun. So I'll take maybe 1 or 2 more requests. Oh, thank you so much, Chuck, for the donation. I really appreciate it. Thank you. Is the blue oxygen gas? Yes, I think so. Yeah, an asteroid. Oh my gosh, I would love to see an asteroid. So the best way to see an asteroid is we'd have to start in the beginning of the night. And so I will make sure we can do this for the next stream. So in the beginning of the night, what we'll do is we'll go to this asteroid and we'll take a picture. And we'll take a picture of the asteroid, and then at the end of the night, we'll take another picture. And then hopefully within the time from the beginning and towards the end of the stream, that asteroid would have moved a little bit. And then we can blink the pictures back and forth, just like how Clyde Tombaugh did to find Pluto. We can blink them back and forth and see the asteroid move. That's my favorite thing to do. I love doing that. And yeah, so we will save that for next time. I'll be sure to get one. Pillars of creation. I don't think pillars of creation are high enough right now. Yeah, we have our Scorpios up though. You know what I love about Scorpio is this star, D Shuba. Some of the stars, I love their names. They're so much fun. Blink comparator, exactly. If you guys haven't visited Lowell and seen the blink comparator, we actually have it here. It used to be in the Smithsonian, but they returned it to us, and so now it's at the Rotunda Museum. All right. Someone said the Black Eye Galaxy, so let's do the Black Eye Galaxy. Let me show you guys where it is in the sky, and then we'll go there. I think it's in Coma Berenices. I think my supervisor earlier was talking about it. Black Eye Galaxy. Oh, what was it typing? Oh, it is in Coma Berenices. There we go. Oh, how cool. Look at this one. we're gonna go to this one. M4 star cluster. Okay, I'll see if M4 is up as well. I'll do that. I'll look it up actually right now. M4. I know M3 and M5 are up, so M4 should be up. Oh, there it is. It's in Scorpio. Oh my gosh. I can't believe Scorpio is so high up. It's right next to Antares, so this one might be tricky. So we're going to do black eye and then M4. So let's go to our Planewave software, and then we'll type in black eye. Black eye galaxy. Right there, Coma Berenices. Very nice. It's almost at zenith. It looks like it's getting high up there. All right, ready? Here we go. Moving it. So that green dot moving is showing how the telescope is actually moving. Nice. All right. I'm going to actually move the stellarium to black eye, just so we can get that view as well in the corner. Have this kind of hanging out. All right, and now let's, it's already coming in. Let's edit this image, change the exposure, bring it down to 17 seconds. See how that looks. Maybe lower the brightness a little bit. Again, I'm not a professional astrophotographer. I'm just doing this in the moment. Changing it. Antares translates to the, yes, the rival of Mars. Yes, that's why I love it, because it's so red. And it's also in the ecliptic, because Scorpio is a zodiac. It's in the ecliptic where the solar system is, so sometimes Mars and Antares are right next to each other. And so what's funny is, you know, Antares, the rival of Mars, or Ant, you know, not, so like not Mars. And so when I tell people, I'm like, yeah, so this star is not Mars. They're like, what is it then? I'm like, not Mars. So what is it? I'm like, it's called not Mars. It's an Antares. And then I say it. Maybe. I just like to give people grief. I'm kidding. So that's a really fun one. So let's change the name to this black eye galaxy. There we go. Did I take the picture? No, I forgot to. But you can see some of the streaking from the stars because I forgot to take the picture. I stopped it and then I didn't start it again. So we just have it on a loop, and I have it at 17 seconds. We'll see how that one looks. J.R.R. Tolkien. Oh my god. Cool. So there is our black eye galaxy. Oh, I love this one. I really like how thick the spiral arms are in this one. You can really see those dust lanes. And so the black eye galaxy is about 24 million light years away. That's a close one. And there's about 100 billion stars in this galaxy. That's kind of cool. Wait, it says distance to Earth 24 million light years, but this one it says 17 million light years away. Interesting. The radius is about 26,000 light years across. Radius, so I guess halfway across. Yeah. Let's see more about it. Isolated spiral galaxy, Coma Berenices. We all knew that, of course. Yeah, this is just a really nice image. Again, you can see the bright core in the center there. It's super bright. And then all around you can see the spiral arms. I mean, let's go back to that stellarium picture. You can see what it looks like on stellarium. Oh no. Pause. There we go. And you can see like the individual spiral arms compared to our image. That's pretty close. We don't have that color, but I think it's beautiful. It's a really nice picture of the black eye galaxy. Cool. Coma Berenices. All right, let's do M4. I'll move it to my plane wave. M4. That's so crazy. You know, time flies when you're having fun, as they say. And it's just crazy that Scorpio is up right now. It just blows my mind. So let's go. Let's move it. You can see, there goes that green dot. There goes our telescope. And let's go back to our picture. And let's change that time. Oh my gosh, it's already there. I'm gonna change it though to about 10 seconds and see what we can get. Again, you can see all that streaking from the stars because I moved it while I was taking the exposure. But I think it looks cool, the galaxy in the globular cluster. Nice. So here is M4. It is a globular star cluster. Right? I believe it is. Yep, globular star cluster in Scorpio. And it's right next to Antares. So it's with our TEC telescope. We have, I don't know if you can see it in this image. The TEC is like right here at the open deck. And you can actually get M4 and Antares in the same field of view, which I think is so cool. That is so cool. So, globular star clusters. There's a theory that globular star clusters are actually the cores of remnant proto-galaxies that the Milky Way sucked up during the formation of the universe. And yeah, globular star clusters are home to some of the oldest known stars. Exactly, because these stars are like 13 billion years old, around the same age as the universe. And, you know, a lot of these other galaxies, because we think these were the center of them. And that's why there's that density of stars. And in some globular star clusters, M15, I think, we know that there are black holes in the center, at least M15. And, you know, there's just so many stars around there, all kind of gravitationally bound, going around, again, what we think is a black hole. Pretty cool. And so these actually orbit the outside of the Milky Way. They're all basically around 30,000 light years away, all orbiting the outside of the Milky Way in what we call our galactic halo. And they all, again, have a lot of very similar features. Globular. That's so funny about astronomy is astronomers are not very creative. So the planetary nebula, the reason why they called it a planetary nebula is because with their telescopes that weren't that's so great at the time, they're like, wow, it's round like a planet. Let's call it planetary. And then they're like, oh, let's look at this cluster. It looks like a glob. Oh, let's call it a globular cluster. Like, so great. Oh my gosh, Paulette, thank you so much for the donation. We really appreciate it. Thank you so much. And we are looking at M4. I have to change the name. M4. There we go. Great loop of stars in the upper left of the image. Are you talking about this here? Maybe. Yeah. This is a very, very beautiful globular star cluster. I really enjoy it. I really, you know, tonight at the observatory we're viewing M5 through the Clark telescope and M13 through a 32-inch telescope, and it was really awesome. I love just showing people globular star clusters. It looks like glitter. It's so pretty seeing all those stars. You know, sometimes I think some people get underwhelmed when they look at a star, but then when you see all the stars all together, it gets people really excited. They're like, that is so beautiful. That's the craziest thing I've ever seen. And I really do enjoy the globular star clusters. They're so pretty. Wow, it's already 11. It's getting late. Okay, maybe I'll do one more. Maybe I'll do one more suggestion. Let me see. Garnet star. That's in Cepheus. Let me go. Cepheus. The only thing is, here's something I do know. about outside. So here's Polaris. So this is the North Star. Everything in the sky goes around Polaris. And right underneath Polaris is where the Godo is, or at least where the building is right here. So this is like facing north. So Cepheus is right behind the Godo right now. So I do know that. So I don't think we can get the Garnet Star, unfortunately, tonight. It moves maybe, you know, towards the end of summer. I think we'll be able to get it. But right now it is just right behind the building. M83. Let's look at that one. M83. Ooh, that looks like a pretty one. Let's do that one. We're gonna do M83. All right. Let's see. Bring this back up. M83. The southern pinwheel. I know this one. All right, here we go. There it goes. And their image is going to change here soon. So let's get in there and edit it. We got that streaking again because we moved the telescope while it was taking an exposure. And we're going to try 15 seconds and see how that looks for this galaxy. M83. Let's look up some facts about M83. M83, southern pinwheel. It's about 15 million light years away. Oh, there she is. Oh, and it has a bar. Look at that. So we're going to increase that exposure 25 seconds. And after this, I'll do some stacking so we can make it. Yeah, fast slew. Exactly. That's the whole, you know, that's the coolest thing about our telescope and like this camera is that we can just move and like go see something and then go somewhere else. Look at that. This one looks so nice though. Yeah, I'm gonna start stacking once this new picture comes in. In about 1 second, it should change. Oh, look at that. Maybe I overexposed it a little bit. I'll bring it down just a little bit. A few seconds. Maybe change some of this. All right, and then after this new picture comes in about 10 seconds, then I'll start stacking it. Yeah, this is nice. This is a really nice galaxy. Let me change it. M83. Beautiful. All right, did it already come in? Did it change? I don't know. I'll start stacking anyway. So yeah, this is a barred galaxy, barred spiral galaxy. So earlier we looked at some spiral galaxies that didn't have a bar in the middle. You know, the Milky Way also has a bar. We think it is a barred spiral galaxy. And so the barred galaxy just means that there's a bar in the center. So we have this bar going through here, and then we can see the arms kind of going out and around there. Yeah, super cool. I like this one. This one's really nice. So, oh, this galaxy is thought to have around 40 billion stars in it. That's crazy. And it was discovered, oh gosh, I'm gonna butcher this name. Discovered in 1752 by the French astronomer Nicolas Louis de la Salle. Oh no. Cool, and it's in Hydra. It's in the constellation Hydra. Very, very cool. You know, let me go back to Stellarium. Hydra is a very, very long constellation. Here it is. I think it's like the longest constellation, if I'm not mistaken. So here's the head of Hydra, and it goes out, all like this. And so it's at the very end of Hydra here. It's a very, very long constellation. We also have Serpens that's up right now. That's also a very long one. Is it Serpens? I don't know. Yes, Serpens here. This is Serpens. We have Hydra, And then we have Lynx. Long constellations here. Let's go back to our image of M83. How cool. All right, so to finish off, let's go back to Leo here. And I totally forgot there's a cool fact about Leo that I wanted to share. So let's see if we can find it on Stellarium, because I know for a fact our telescope will not be able to get it. We're going to try to see if Stellarium can get this red dwarf in Leo. It's called K218. Yeah. All right, so let's zoom in. Oh, Stellarium doesn't even have a picture of it. Oh my goodness. So right here, right where this little, circle is, underneath Leo, there is a red dwarf star called K218. And the reason why I bring this up is because, we think almost every single star in the sky has at least one planet around it, or exoplanet. But what's cool about K218 is there is a planet called K218b. And K218b was discovered via transit. And so what happens is, when a planet goes in front of a star, the star has like a constant brightness, let's say. And when the planet goes in front of it, it kind of dims that star's brightness just a little bit. So when we look at something called a light curve, the brightness of that star, it can be like, let's say like a constant line, and then it just dips a little bit and then it comes back. And so that's how we can discover some planets, is when they just pass right in front of the star. So transit, when it just goes in front of it. And so this exoplanet was discovered when that happened. And yeah, a red dwarf star. They're not very hot stars, they're cool stars. So we're talking about the white dwarfs. So that's, the remnant of a dead star. So these red dwarfs, they're like that, but even cooler. There's really cool stars. And so K218b is very, very close to its host star, this red dwarf. It's a very cool star. And we actually think that it is a rocky planet that is potentially habitable. And so what they think is there could be liquid water on the surface. It is 2.2 times bigger than Earth. And that they do think it may be a water world with an ice shell or thin atmosphere, which is really cool. Can they figure out an estimate of the planet size based on how much it dimmed? Yes, exactly. They can. What time does Bolo play? Don't know what that means. Mystery object. I don't know if I could go there. And anyway, so potentially habitable planet in Leo, which I think is so cool that in Leo, around this red dwarf star, there's potentially an icy world, which I think is so crazy. Did you mention how far away this red dwarf is? I did not. Let's see. K218. I think it is 124 light years away from Earth in Leo. So that's something I'm hoping to do in each of these streams, is talk about some of the exoplanets around some of these stars, because I think that is so fascinating. Astrobiology is, again, one of my interests. I'm studying those dang spiders, but I'm more interested in planetary science, so things in our solar system, things that are a little bit more tangible for me. So going to Mars, going to asteroids, accessible asteroids, accessible planets, things like that. Hopefully we can find bugs on Mars, and I will name one. All right, so yeah, I think we will just leave it with that beautiful picture of Leo and M83. So yeah, thank you guys so much for joining this evening. We had so many great requests. We will keep you guys updated on Lowell's Instagram and Facebook on the next time we have this stream. I do believe we'll have it towards the end of next month. Stay tuned and follow us on YouTube, subscribe, and turn the notifications on so whenever we do have a live stream, you'll get notified. And just keep up to date on our social media. We also will have a link to our new Discord server. So if anyone uses Discord, we have a Discord server that we've worked very, very hard on. So please join that if you want to keep in with the conversation, and if you have any suggestions or requests or anything for the future, live streams or just in general, we're taking all feedback. So definitely join our Discord server and just chat with us there. And yeah, thank you guys so much for joining this evening. I had so much fun, and I'll see you again next time. Thanks for joining in. Bye, everyone.